All right, so we're going to review vertical motion problems. I'm going to show you how you can use integration to solve these vertical motion problems. So if you remember from a few units back, we were always discussing some position function. And the position function always started out something like this: negative 16 t squared plus initial velocity time plus standard position. Now, also, if you remember in that unit, we talked about how I can take the derivative of the position function, and when I take the derivative of the position function, I get the velocity function. And then I can take the derivative again of the velocity function, or I could take the second derivative of the position function, and I get my acceleration. All right, so what we're going to do is we're going to work with a vertical motion problem, and I'm going to use integration to solve it. All right, so let's see. All right, so we're going to take a ball being thrown up with an initial velocity of 64 feet per second and an initial height of 80 feet. So an initial velocity of 64 feet per second and an initial height of 80 feet. All right, so I know that my position function is going to be negative 16 t squared plus 64 t plus 80. I know that's my answer, but I'm going to use integration to show you how we come up with that. All right, so I know that my acceleration due to gravity is negative 30 feet per second squared. So my acceleration is negative 32 feet per second squared. Now, I want to work backwards. So if I integrate my acceleration function, I will find my velocity function. And if I integrate my velocity function, I'll find my position function. Now, I already know what my position function is, but I'm going to show you how we use integration to solve this. All right, so when I integrate my acceleration, I get v of t is equal to negative 32t plus some constant. All right, so now we have some initial criteria here. It says my initial velocity is 64 feet per second. So if my initial velocity is 64 feet per second, it means that when my time is 0, my velocity has to be 64. So I'm going to use that initial condition to solve for my c value. So when my time is 0, my velocity is 64. Okay, and if I solve that, this whole thing is just 0, so I get c equals 64. All right, so let's move that up. So that means that, let's get rid of this guy here. I have my acceleration, which is negative 32. I have my velocity function, which is negative 32t plus c. When I solve for c over here, I got 64. All right, now if I integrate my velocity function, I will get my position function. So I'm going to integrate v of t. When I integrate v of t, I'm going to get s of t. So I add 1 to the exponent, divide by it. 64 now gets a t plus c. All right, so now I can find my C value because I know that my initial position is 80. So to find my C value here, I'm going to plug in 0 for time because no time has passed and it will be 80 feet above the ground. So I'm going to put in 0 in the time spot. And when the time is 0, the height is 80. So I'm just going to divide -32 and 2. So I get 16 times 0 squared plus 64 times 0 plus C. Okay, so now if I solve this, this becomes 0, this becomes 0, so I just get C equals 80. So that means that my position function is -16t squared plus 64t plus C, which I got 84. Okay, so now I have my 3 different functions. I have my acceleration, I have my velocity, and I have my position function. And now I can answer a bunch of questions about this. So one of the typical questions we got was, when does the ball hit the ground? So anytime they're asking you about a height, you're going to use your position function. Anytime they're asking you about a velocity, you're going to use your velocity function. So they want to know, when will it hit the ground? So I'm using a position function. The height of the function will be 0 when it hits the ground. And then I have to solve this quadratic. So they all have a 16 in common, so I could divide out that 16 to make it a little bit easier. So I have 0 equals, I'm going to divide the -16 out, t squared minus 4t minus 5. Okay, and looking for factors of -5 that give me -4, nice and easy to factor. I have t minus 5 and t plus 1. So my time is equal to 5 and -1. And then, of course, we can't keep a negative time value. So it's going to take 5 seconds for the ball to hit the ground.